My dear students, today I am going to discuss Ohm's law. This is included in the electricity chapter of class 10. Now, before we go to the statement of the law, let us see first an activity. Actually, this is an experiment which students are supposed to do in laboratory. Okay. Now, this is the diagram of that activity or experiment. Now, what all things you need, you see? You need battery, you need an ammeter, you need a voltmeter, then resistor, and then of course connecting wires. Now ammeter is a device, it is an instrument with the help of which you can measure current in the circuit. So what current is flowing in the circuit will be shown by the ammeter. So this voltmeter is the instrument or device which will measure the potential difference between the two terminals of the resistor. So here this is a resistor, this is a symbol of resistance. This is a resistor P and Q are terminals. Now between P and Q the potential difference is what? So that will be shown by the voltmeter. Now this is a switch. This is a switch. If you put a dot in between the brackets, that means the switch is on. If there is no dot, that means switch is off. All right. So this is how you will arrange. So this is a resistor. Then the two terminals will be connected to a voltmeter in parallel. A voltmeter is always connected in parallel to a resistor, whereas an ammeter is connected in series with a resistor. So that is very important when you do the connection. So ammeter should be connected in series with the resistor, whereas voltmeter is connected in parallel to the resistor. All right. Then the circuit will contain the battery, the switch, that way. Now we have taken, suppose you have taken a battery of 6 volt, a battery of 6 volt. Now since there is only one resistor in the circuit, the potential difference between the two terminals of the resistor will also be 6 volt. So 6 volt is the potential difference or voltage of the battery. Then the same 6 volt will be the potential difference between the two terminals of the resistor, because there is no other resistor in the circuit. And this 6 volt will be shown by the voltmeter. And then when you put the switch on, when you put the switch on, current will flow. Now current will flow in this direction. So this arrow indicates the direction of current. Current always flows from positive to negative. This longer line means positive, shorter line means negative of the battery. So current will flow from the positive, it will go this way, at this point it will go this way, then also through the resistor, then this way, and then back to the negative of the battery. All right. Now you are using a 6 volt battery. Potential difference across the resistor, that means between the two terminals of the resistor, is 6 volt. 6 volt will be shown by the voltmeter, and then what current will flow, that will be shown by the ammeter. And suppose 2 ampere current is flowing, so this 2 ampere will be shown by the ammeter. All right. Now this must be recorded in a table, so we are going to record it in a table. All right. Now potential difference 6 volt. So we have used one battery, potential difference 6 volt. All right. Then current that is shown by the ammeter is 2 ampere. Okay. So this 2 ampere is shown by the ammeter, and this 6 volt is shown by the voltmeter. Okay. Now next what we do, we use now 2 batteries. So when you use 2 batteries, the voltage will be 12 volt. Now it is 6 volt. Now we use 2 batteries. So therefore 6 plus 6 will be 12 volt. Now immediately that 12 volt will be shown by the voltmeter. So the voltmeter will show 12 volt. That means 12 volt is the potential difference between the two terminals of the resistor. All right. Now the ammeter will show what? Ammeter will show 4 ampere. So 4 ampere. Because you have doubled the potential difference of the battery, so the current will also be doubled. Previously it was 2, now it will be doubled, because this is double, so this will also be double. All right. Now next we use three batteries. So 3 batteries, total voltage will be 18 volt, and then obviously this will also become 18. So the voltmeter will show 18 volt. So we are using now 3 batteries. 3 batteries, total voltage is 18. Total voltage or potential difference is 18. That is shown by the voltmeter. So 18 volt is the potential difference between P and Q. And now current will be, yes, 3 times the original. Originally it was 2. Now it will be 6 ampere. So that will be shown by the ammeter. So this is how you will find when you do the activity in the laboratory. All right. Now next we will use 4 batteries. So 4 batteries, total voltage will be 24, and that will be shown by the 24, that will be shown by the voltmeter. That means 24 volt is the potential difference between P and Q. That will be shown by the voltmeter, and this time current will be what? 8. Current will be, this is 24 volt and current will be 8 ampere. This is what you will find. This is what you will find when you do the activity. When you are using one battery of 6 volts, suppose the current is 2 ampere. Then if you double the voltage of the battery, that means use 2 batteries, then it will be doubled. If you treble 3 times, 3 batteries, then this will become 3 times, 3 to the 6. Now you use 4 batteries. So total voltage is 24 volt. So it will be 4 into 2, 8 ampere. All right. Now in this column, we are going to find out V by I, ratio of V to I, this value by this value. So what will be V by I? V is 6 and I is 2. Now I is the symbol of current. All right. V is a symbol of potential difference. V means volt. I is the potential difference of the symbol of the current. I is the symbol of the current. But SI unit is ampere. SI unit of electric current is ampere, A. But symbol of electric current is I. Then this V is the symbol of potential difference. And that is also the symbol of SI unit of potential difference, which is volt. Okay. Now V by I. What is V by I? 6 by 2. 6 by 2 means 3. So V by I is 6 by 2, 3. And here 12 by 4, 3. So V by I, 12 by 4 is 3. V by I, 18 by 6 is 3. Then V by I, 24 by 18 is 3. So when you do the activity, you will find this ratio V by I, V to I is always same. That means constant. So this conclusion, after doing the activity or experiment, what conclusion we gather? The conclusion is that the ratio V by I is constant. The ratio V by I is constant. So therefore, what is our conclusion from the experiment? So V by I is constant. It is a constant value. And what is that constant value? 3. All right. So this is what we find from the activity. And from this result, now we can give the statement of the Ohm's law. All right. Now the statement of Ohm's law will go like this. So potential difference between the two terminals of a resistor, the ratio of potential difference between the two terminals of a resistor to the current flowing through the resistor is always constant. All right. So what will be the statement? The ratio of the potential difference across a resistor. Across a resistor means between the two terminals of the resistor. So ratio of potential difference across a resistor, that means between the two terminals of a resistor, is directly proportional. Now see, from knowledge of mathematics, if a ratio is constant, then we say those two terms are directly proportional. So this knowledge comes from the chapter of proportionality or variation in maths. In maths, there is a chapter of proportionality or variation. So in that chapter, so what is said? If a ratio is constant, then the two terms are directly proportional. That means if x by y is constant, if x by y is constant, a number, constant value, then we say x is proportional to, x is directly proportional to y. So this is the knowledge from the chapter of proportionality in maths. If x by y is constant, then x is directly proportional to y. Now we find here v by I is constant, therefore v by I is constant, therefore v is directly proportional to I. Alright? So ratio of potential difference across register is so we'll say this way. Yes, this is a statement. We'll write it this way. Potential difference across a register is directly proportional to the current. To the current. This I is the current. To the current flowing through the register. Flowing through the register. So this is the statement of the Ohm's law. The potential difference across a register, potential difference between the two terminals of a register is directly proportional. That means V is directly proportional to what? To the current I flowing through the register. So potential difference is directly proportional to the current. This is what? This is the main thing of the Ohm's law. Potential difference is directly proportional to current. So symbolically we write that is, so I will write this V directly proportional. This is a symbol of directly proportional to I. Alright. So V is directly proportional to I because we have found V by I is constant. This constant 3. Therefore, what we conclude? V is directly proportional to I. And this is the formal, this is the mathematical representation of Ohm's law. And what is the statement of the Ohm's law? This one. Potential difference across a register, that means between the two terminals of a register, is directly proportional to the current flowing through the register. Now there is an important condition. So provided temperature remains constant. Provided temperature remains constant. Now, suppose you are doing the activity at a certain temperature, room temperature of 30 degree. So, as long as 30 degree temperature remains in the room, this will be 3. All will be 3. But suppose temperature changes, then it will be no more be 3. Maybe it will be 2.5, 2.5, 2.5, 2.5. That means this current will change. This potential difference, this battery, this will remain same. So, this column will change if temperature changes. So, therefore, this law has a qualification. And what is qualification? Temperature should be constant. Now, if temperature changes, then these values will change because this current will change. But whatever value this V by I is, they will be same. Now it is 3, 3, 3, 3. Now, if temperature changes, maybe it will be 2.5, 2.5, 2.5, 2.5, or even 4, 4, 4, 4. They will be constant. Only thing, the value will change if temperature changes. All right. Therefore, when you state that state the law, you have to mention also this at a certain temperature. Okay. So this is the thing, activity and this. So this is the now. This is a mathematical representation. Now from here we get that is V by I equal to what? V by I equal to constant. Now this constant is represented by this letter. So V by I is constant. So here we found constant 3. Now this constant is represented by R. And this R is called This R is called resistance, resistance of the resistor. So V is proportional to I. V by I is constant. So that we have found from the experiment. Now this constant is symbolized by capital R. Now this capital R indicates resistance of the resistor. All resistors have a permanent quality resistance, and that is R. So V by I equal to R. This is the mathematical formula. This is the formula of Ohm's law. So you see, this is the statement of Ohm's law, and this is the formula of Ohm's law. Again I say, remember, this is the statement of Ohm's law, and this is the formula of Ohm's law. Now since you have got a formula, there will be numerical sum in exam where you have to use the formula. Wherever there is a formula, there are numerical problems. Okay. All right. So this is about the Ohm's law. Now we come to the next important thing about Ohm's law. That is the Ohm's law graph. Ohm's law graph. Okay. Now for drawing a graph, you need a table. So you have seen in maths, for drawing a graph, you need a table. Now already you have got a table. Now using this table, we can draw a graph using x-axis and y-axis. All right. Okay, let us see now the Ohm's law graph. Ohm's law graph, which is also called VI graph. Ohm's law graph or VI graph. Ohm's law graph or VI graph. VI graph. VI graph of resistance. By the way, one thing here. So you have seen this SI unit of potential difference is volt. SI unit of current is ampere. Now SI unit of resistance, so V by I equal to R. So already we got the formula V by I equal to R. So V by I equal to R. So this R is the resistance, and its SI unit is ohm. This is a symbol of ohm. This is a Greek letter called omega. This is a Greek letter called omega, which is the symbol of SI unit of resistance. So SI unit of resistance is ohm. SI unit of resistance is ohm, and the symbol of ohm is this Greek letter omega. So 3 ohm, 3 ohm, 3 ohm, 3 ohm. All right. Okay, now let us see the VI graph of resistance. VI graph of resistance. So for a graph, as you know, you need what? You need x-axis and y-axis. This is the x-axis and this is y-axis. All right. This is the origin. Okay. Now VI graph. So along this x-axis we take current. We take I. We take I along x-axis, and we take potential difference V. Potential difference V along y-axis. So along y-axis we place potential difference this, and along x-axis I, current. Okay. Now current is 2, 4, 6, 8. So let us see. Suppose this is 2, this is 4, this is 6, this is 8, this is 10, like that. So this is 2, 4, 6, 8, 10, etc. So this is along x-axis. This is the origin. Origin is 0. And along y-axis what? Potential difference V. 6, 12, 18, 24. So suppose this is 6, this is 12, this is 18, this is 24. So 0, 6, 12, 18, 24. So here 0, 2, 4, 6, 8. All this is ampere and this is volt. Okay. All right. Now first point will be what? So x coordinate first. So 2, 6. First point will be 2, 6. So 2, 6 will be which point? Say if you are drawing on plain paper, then you have to show this dotted line. So this point is what? This point is 2, 6. 2, 6. Now the next point is 4, 12. 4, 12. all right, 412, all right. The next point is 618, 618, 6 and 18. Okay, 6 and 18. And next point is what? 824, 824. Now all these, if you join these points, you should get a straight line. That is the point. You see this, okay? So these are the 4 points. Of course, these are 90 degree, 90 degree, 90 degree, 90 degree, isn't it? Okay, now joining these points, you will get a straight line. Now, I mean, these points, sometimes you don't get exactly collinear. You don't get exactly straight line, but near about, okay? So, let me join this. So, we should get a straight line. We should get a straight line, all right? Yes. So, suppose this one. So, this is straight line, suppose OA. So, OA is the graph. OA is the graph. OA graph represents what? OA graph represents resistance. Resistance of that resistor which you use for the activity. So OA graph represents resistance. All right. So this is called resistance graph. Now resistance graph is always straight line. Sometimes you are asked in exam, why it is straight line? Because it is constant. Resistance is constant. Constant means uniform. So in class 9 you did this straight line graph for uniform velocity, uniform acceleration in class 9, which is always a straight line. So straight line means uniform, that is constant. So why this Ohm's law graph, the VI graph, Ohm's law graph of resistance is straight line? Because this resistance is uniform or constant. Therefore, this is why you are getting a straight line by plotting these points. Okay. So this OA graph represents resistance of the resistor which we used. Now there is a question. What does the slope of this graph, slope of the graph OA represent? Represent what? So this is an important question. So slope of this graph represents what? So what is represented by slope of this graph OA? Now this idea of slope, again you did in class 9 probably. So slope is actually in a slope or gradient in terms of trigonometry. It is tan theta. Slope or gradient is actually tan theta. But here without trigonometry we will say slope is ratio of y coordinate by x coordinate. So what is slope? Slope is equal to, slope is y coordinate by x coordinate. Y coordinate of a point by x coordinate of that point. So take a certain point, so y coordinate divided by x coordinate, the ratio of y to x. So that is slope. Now suppose you consider this point. Now this point is what? This point is 824. So this point is 824, isn't it? So this is 824. What are the coordinates of this point? 824. Now y coordinate is 24, x coordinate is 8. Therefore, slope of OA will be what? Slope of OA is equal to y coordinate. Y coordinate is what? 24. 24. And x coordinate 8. 24 by 8. That means 3. So you see, slope of this graph is 3. Now we have found slope by taking which point? This point. Now you can take this point also, no problem. Now what are the coordinates of this point? The second point, 412. Coordinates of this point is what? 412. 412. Therefore, what will be the ratio? What will be the ratio of y coordinate by x coordinate? Will it not be 12 by 4? So y coordinate is 12, x coordinate 4. So 12 by 4, again you will get 3. So take any point on this graph, then y coordinate of that point divided by x coordinate of that point. So that is called slope. Now slope of this graph represents what? Slope of this graph represents what? Resistance. So what is this 3? Resistance. So answer is what? Question was slope of this graph represents what? So what is represented by slope of this graph? So answer is slope of this graph represents what? Resistance. Represents resistance. That is the answer. Slope of this graph represents resistance. Now in terms of trigonometry, it is tan theta. Suppose this angle you call theta. Suppose this angle you call theta, and you consider this right angle triangle. This is a right angle triangle. All right. Now what is tan theta? Those who have learned trigonometry. So tan theta is what? Perpendicular by base. So this by this. Now this is 24, this is 8. So 24 by 8. You see, 24 by 8. So I mean, in terms of trigonometry, slope is tan theta. But without trigonometry, what is slope? Y coordinate by x coordinate. So slope of resistance graph or slope of VI graph represents what? Slope of VI graph represents resistance. Slope of VI graph represents resistance. Okay. Now there is another graph. This is the VI graph. Now suppose we draw IV graph. IV graph. Now come to the just reverse IV graph. So this is x-axis, this is y-axis. All right, x-axis, y-axis. Now, so we are going to draw VI graph, IV graph, IV graph. IV graph. IV graph, so this will be I. This side will take I and this side will take V. So IV graph, all right. Along x-axis V, along y-axis I. So along axis V, what are V values? 6, 12, 18, 24. So 6, 12, 18, 24. This is origin 0. And what is I? 2, 4, 6, 8. So 2, 4, 6, and suppose this is 8. So this is IV graph. Okay. Now, so this 6, 2, 6, 2. So 6, 2 will be 6, 2 will be somewhere here. Then next will be 12, 4. First is 6, 2, then next 12, 4. 12, 4 will be somewhere here. So this will be 6, 2, this will be 12, 4. Then 18, 6. 18, 6 will be somewhere here. Then joining these points, again you will get a straight line. So next point is what? 8, 24. 8, 24, 8. 24, 8 will be somewhere here. Yes. So this is 24, 8. Now this point is 18, 6. This point is 18, 6. 18, 6. Now this point is what? 12, 4. 12, 4. And this point is, first point is what? That way, 6, 2. This is 6, 2. So 6, 2, 12, 4, 18, 6, 18, 6, and 24, 4. So these are the 4 points. All right. Now here, slope of this graph. Now see what is the slope of this graph. Now slope of this graph is what? Slope equal to, say take any point this. So y coordinate by x coordinate. Y coordinate is 8, x coordinate is 24. That means 1 by 3. If you take this point, then it is 6 by 18. 6 by 18 will be again 1 by 3. If you take this point, 4 by 12, that will be 1 by 3. If you take this point, 2 by 6, that is 1 by 3. Now slope of this graph OB is 1 by 3. Now 1 by 3 is what? 1 by r. Because what was r? So in this case, in the previous case, what was resistance we found? Resistance equal to 3, no? We found resistance 3, this one. So V by I is R. So resistance is 3, but now we are finding 1 by 3. So 1 by 3 will be what? 1 by R resistance. All right. So slope of this graph, now this graph is called conductance graph. So this is not resistance graph, this is conductance graph. Opposite of resistance, conductance. So previous graph was VI graph of resistance. Now this time it is IV graph of conductance. Conductance is the opposite of, it is the inverse of resistance. If resistance is 3, then conductance is 1 by 3, you see. Now slope of this graph is what? 8 by 24 or 4 by 12, etc. We get 1 by 3. Now 1 by 3 is what? 1 by 3 is conductance. All right. So slope of VI graph represented what? Resistance, and slope of IV graph represents what? Conductance. Okay. But this graph, conductance graph, is not given in the syllabus of class 10. Sometimes, rarely it is asked. Okay. All right, for today this is all about Ohm's law and the graph. So next time we may discuss some numerical problems and some other questions related to Ohm's law. Okay. All right, I hope this had been beneficial to you. If you think you are benefited, then share and subscribe to my channel. All right.